Katie invests £2,000 in a savings account for 3 years. This account pays compound interest at an annual rate of 2.5% for the first year and X% for the second and third years. There is a total amount of £2,124.46 in the savings account at the end of the 3 years. And part A says we need to work out the rate of interest in the second year. So now I've written down here a definition for compound interest. So my definition is that you earn interest on both the money you have saved and the interest you earn. So essentially, using Katie's investment up here as an example, with compound interest, originally, Katie invests £2,000. So for the first year, the 2.5% interest is applied to the £2,000. But because of the interest at the end of the year, Katie's going to have more money. So then for the second year, all of that money is essentially put back in the pot. And this interest is applied to all of the money, so the £2,000 and the interest earned in the previous year. This is different to the other type of interest you'll come across in GCSE maths, which is simple interest, when each year the interest is only applied to the original amount, so it would only be applied to the £2,000 here. Okay, so I'm going to do this year by year. I'm going to start off looking at year 1. So it says in the question that Katie starts off with £2,000. In the first year, there's an interest of 2.5%. So we need to increase this by 2.5%. So to do that, we times by 1.025. And you might just know that that's what we need to multiply by when you're given a percentage. However, there's a little formula that we can use to work that out. So we can do 1 plus the percentage, so in this case 2.5, divided by 100. So that's how I got from the percentage to the number I need to multiply. And this sort of little formula thing is really useful, and we're going to come back to it in a minute. Okay, so putting this into the calculator, we get that at the end of the first year, Katie's going to have £2,050. Great, so we're now going to move on to year 2. So in year 2, and remember, because it's compound interest, all of this money is going to be the starting point. So you're going to feed that back in starting with £2,050. And we're told there is an interest of X%. But obviously, we don't know what that is at the minute, but we're going to write it in using this sort of formula thing. So we're going to multiply by 1 plus the percentage, so in this case it's X, divided by 100. I'm going to remember these brackets here because we're multiplying all of this by this. Okay, great. I'm now going to move on to year 3. So in year 3, all of this is going to be our starting point. So we're going to start with that. We've got 2,050 multiplied by 1 plus X over 100. So that's our starting point. And then we're told up in the question, again, it's X% interest for the third year. So the same as last time, on top of our starting point here, we're going to multiply that by 1 plus our interest, so X% over 100. Okay, so now we need to work with this to find out what X is. And the way to do that, we need to make an equation. And luckily, if we look back into the question, we see that the total amount of £2,124.46 is in the savings account at the end of the 3 years. So I'm going to do up here, I'm going to write out an equation using that. So we're going to say our 2,050 multiplied by 1 plus X over 100, multiply again by 1 plus X over 100, equals what we were told in the question. So 2,124.46. And one thing I notice here is we've got two terms that are identical, and we're multiplying them together. We can actually write that as a single term squared. So to write this a bit more simply, I'm going to rub this out. I'm going to write that. It means the exact same thing, but I'm going to write it as 1 plus X over 100 squared, because we're multiplying by it twice. Okay, great. So now what we need to do is solve this to work out what X is. So I'm going to start by dividing both sides by 2,050, which is going to leave us with 1 plus X over 100 squared. And using the calculator, we get that this is going to be 1.0363 ... But I'm going to leave the full long number stored in the calculator so we can keep on using it. I'm then going to square root both sides. So on the left hand side, I'm left with 1 plus X over 100 equals the square root of 1.0363 ... So I'm going to put that into the calculator, and we get that is 1.01799 ... So now if I subtract 1 from both sides, we get that X over 100 equals 0.01799 ... And multiplying both sides by 100, we get that X equals 1.799 ... which equals 1.8 if we round to one decimal place. And there we got the answer, because the question asks us to work out the interest in the second year, and the interest is X%. So we've worked out what X is. So therefore, our answer down here is that the interest in the second year is 1.8%. We get 1 mark up here for the first year calculations. We get a second mark for going through the process and forming an equation like this. We get another mark for going through the process to solve for X. And we get our final mark for the correct answer of 1.8%. However, something to point out with this question, because it's not specific of how you should round it, we get the final mark for any answer between 1.79% and 1.8%. So in this case, I've gone for 1.8%. Katie goes to work by train. The cost of her weekly train ticket increases by 12.5% to £225. Part B says we need to work out the cost of our weekly train ticket before this increase. Right, so firstly, I'm going to let C, so the variable C, so that could be any letter, I've just called it C, be the cost before the increase. So we're going to create an equation that we can solve for this. So the cost before the increase is C, and that's what we want to work out. Then we're told that that increases by 12.5%. And we can use our little handy formula thing up here to work out what we need to multiply that by. So we're going to multiply by 1 plus, and because we're increasing by 12.5%, I'm going to put 12.5 up here, divided by 100. And we're told that after the increase, the cost is 225. So that will equal 225. Now we need to solve for C. So I'm firstly going to work out what's in this bracket. So we're going to have C multiplied by 1.125. And that's again equal to 225. Then if I divide both sides by 1.125, we're left with C on the left hand side. And that's going to equal 200. And that's the answer to the question. Before the increase, the cost of the train ticket was £200. So you get 1 mark here if you're working out. So for dividing 225 by 1.125, then you get the second mark for the correct answer of 200.